Di ba, as I have posted doon sa Facebook group natin, I told you guys na yung may kulang pa ako na lecture sa inyo from statics, which is chapter 9 and chapter 10, centroids and moment of inertia. Okay, so supposedly, it should be a recorded video that will be loaded on our MS Teams. Okay, kaya lang, I decided na instead of a recorded video, on na lang podcast, okay, yung chapter 9 and chapter 10. Okay, kasi ano na din naman, gagamitin nyo din siya pagdating natin ng chapter 5 ng mechanics of deformable bodies, which is the stresses in beams. Okay, so kumbaga, I need to understand fully, okay, yung centroids and moment of inertia. Okay? Kaya yun. So, and we'll have an online meeting. Okay, so online discussion for chapter 9 and chapter 10 of statics. Then the following week, okay, ano na yun, okay, and as recommended by other sections, they prefer a recorded video. So I concur na recorded video na lang kasi as I have noticed, very few students na okay. So kaya recorded video na lang, tas if you really have questions, then we can have an online meeting. Please coordinate with your class representatives. Okay, then we can where I can answer your questions or yung mga hindi nyo talaga maintindihan. So we can clarify some things dun sa lecture, etc. Okay? So, but for now, we'll have and center of gravity as our lecture. Okay, so this will be a recorded video. This will be a recorded meeting. So after the meeting, this video will be uploaded on your MS Teams as well as the presentation. Okay. Then during discussion, you can unmute, so you can ask your question anytime. Okay. Then or you can post it in the chat. Okay. Question. Okay. So start ko na yung recording. Then yung lecture. Okay. So chapter 9 is center of gravity and centroid. For chapter objectives, so to discuss the concept, the center of gravity, center of mass, and the centroid. Then to show how to determine the location of the center of gravity and centroid for a body of arbitrary shape and composite parts. Then to use the theorems of Pappus and Goulmus for finding the surface area and volume for a body having axial symmetry. Then yung last objective will not be discussed here. Ituturo din naman yun pag nagkaroon kayo ng fluid mechanics. Okay? So for now, we'll focus on these 3 chapter objectives. Then center of gravity, center of mass, and centroid of a body. So knowing the resultant or total weight of a body and its location is important when considering the effect this force produces on the body. So the point of location is called the center of gravity. We will show how to find it for an irregular shaped body. Then we will then extend this method to show how to find the body center of mass and its geometric center or centroid. So first, center of gravity is of an infinite number of particles of differential size. And so if the body is located within a gravitational field, then each of these particles will have a weight dW. So these weights will form a parallel system is the total weight of the body, which passes through a single point called the center of gravity or G. Okay. So say consider the radiation. Okay, so similar with our discussion before, okay, so around chapter 4, okay, yung resultant ng parallel force systems or that's distributed loading. Okay, say itong rod na to is composed of okay, so each particle has a weight dW. Then if you want to solve for the resultant, okay, we just sum of forces. Okay, so that's why we have Fr is equal to okay, and the resultant is W, and that is equal to the sum of the components. And we know one of the component is dW, and if you want to get the sum, we apply integration. Okay. So we equal to integral of dW. Then as for the location of the center of gravity G, where this W is acting, okay, we will apply Varignon's theorem. So if you can recall, Varignon's theorem states that the moment of the resultant is equal to the sum of the moments of the components. So if the resultant is W, so its moment arm is bar X. If you are taking moment about the y-axis is dW, and its moment arm about the y-axis is X curl. Okay, so therefore, okay, by applying Varignon's theorem, we have W times bar X W because okay, this product X dW, if you want to get the sum, we apply integration. Okay, so since we are looking for the location of the center of gravity of bar X, by W. Then from this equation, we have W is equal to integral of the W. So that's why we have bar X equal to integral of X curl. So the curl dW divided by integral of the W. Okay. Then for a plate, okay, so the weight is acting through the center of gravity, and the location is at bar X and bar Y distance from the origin parallel to the X and Y axis, respectively. Then for dW, the location is at X curl and Y curl. So bar X equal to integral of X curl dW over integral of dW, and bar Y is equal to integral of Y curl dW over integral of dW. Then for the center of gravity of the general three-dimensional body, okay, so we have these formulas. Bar X equal to integral of X curl dW, okay, over integral of dW. Then we have bar Y is equal to integral of Y dW over integral of dW. Bar Z is equal to integral of Z dW over integral of dW. Okay, so this is the general case. Okay. So yun. So that's the center of gravity. So the center of gravity is where the weight is acting. The resultant weight is acting. So that's why we need to locate the center of gravity. Now, for the location of the center of mass of a body, okay, so that is used, okay, in the study of dynamic response or accelerate a body. So it is important to locate the body center of mass. And this location can be determined by substituting dW is equal to G times dm. So if you can recall from physics, weight is equal to mass times the gravitational acceleration. Okay? So if you have a particle dW, okay, so that is the differential weight acting on the differential m. Okay? So ayun. So we have dW is equal to okay, dm times g. Okay? So from the previous equation, so we'll just replace dW by its equivalent dm times g. Okay? By doing so, provided that g is constant, it will cancel out. So, okay, yung formula natin becomes bar x equal to integral of x over integral of dm, bar y is equal to integral of y curl dm over integral of dm, and bar z is equal to integral of z curl dm over integral the location of the center of mass. Okay? Then for the centroid of a volume, so if the body is made from a homogeneous material, then its density rho will be constant. So therefore, one element of volume dV has a mass dm which is equal to rho dV. So similarly, from your physics, okay, you know that rho, okay, the density. So if you want to solve for the mass, that would be equal to the rho, the density multiplied by the volume. So if you have a differential mass, that would be equal to the density multiplied by the differential. Therefore, if we're going to replace dm in these equations by its equivalent rho times the differential volume, okay, we'll have these formulas. Okay, so substituting and canceling out that locate the centroid C or the geometric center of the body. Okay, so that is bar x equal to integral of x dv over integral of dv. Then we have bar y over integral of dv. Then bar z is equal to integral of z dv over integral of dv. Okay? So those are the formulas for the center of gravity, center of mass, and the centroid of a volume. Okay? Now, what if we have an area? Okay? So if we're going to solve for the centroid of an area, okay, we're gonna do it. Okay? So, ito yung inaaral nyo nung calculus nyo, no? Okay, yung centroid or area of bounded by different curves. Okay? So, say, if an area lies in the xy plane bounded by the curve y is equal to f of x, then its centroid will be in this plane and can be determined from the integrals. Okay? So say you have this x and y axis, then you have which is y equal to f of x. Okay, so these curves, they will bound this area, okay, and this area has a centroid C. So if you want to locate the location of the centroid bar x and bar y, we'll apply integration. And how? Okay? So ang ginagawa before sa calculus is, syempre, we need to divide this into number of strips. Okay? Syempre, so depende sa strip na kino-consider mo, okay, magiging mas accurate, okay, yung sagot mo. So the more, okay, the strips you have, the more accurate the result will be. Okay, kaya that's why, so if we'll choose a strip that is very small, that's why its width is only dx. So alam natin, dx is infinity. Okay, so dx. Okay, so this point is at point x and y. So therefore, if you have a rectangle, okay, this is the location of the centroid of this element. Okay, and x curl and b equal to x and y over 2. Okay, kasi if this point is at x and y, so meaning the height of this rectangle will be equal to y and its width is d. So if you want to solve for the area, that is equal to integral of dA. So that is equal to integral of dA. Okay? And based from this, the differential area that we are considering is that of y times dx. Okay? So this is the point of determining the area from integral calculus. Okay, so alternatively, instead of having a vertical rectangular strip, you have a horizontal strip. Then from there, you can solve for the centroid of the area. That will be equal to bar x equal to integral of x curl dA over integral of dA, and bar y is equal to integral of dA. So these integrals can be evaluated by performing a single integration if we use the rectangular strip for the differential area element. The next, centroid of a line. So if a line segment rod lies within the xy plane and it can be described by a thin curve y is equal to f of x, then its centroid is determined is the curve that we are, or the line segment that we are looking for the location of the centroid. Okay, so this is the formula that can be used. So bar x equal to in xdl over integral of dl, then bar y is equal to integral of y curl dl over integral of dl. So that is in the domain of the length. Okay? Take note, itong kukunin natin na element dl, okay, can be formed in this Pythagorean. So that's the hypotenuse of Pythagorean. That is the hypotenuse of the triangle. Okay? So therefore, by applying Pythagorean for the differential element, okay, okay, dl will be equal to square root of dx squared plus dy squared, which can also be written in the form dl is equal to square root of dx over dx squared plus dy over dx squared. Okay, so it will give you dl is equal to square root of 1 plus dy over dx squared. Okay, dx. Or dl is equal to square root of dx over dy squared plus 1 dy. Okay, so the question is, okay, which one are you going to use? So the equation, okay, so if the line kung yung line ay merong equation na mas madali, kasi take note okay, the term here is the first derivative of y with respect to x, while this one is the first derivative of x with respect to y. So it depends on the equation of the line, okay, whichever will give you a more easy solution, okay, you can choose one, okay? But take note, either of these can give you the answer you are looking for. Okay, so sample problem 9.1. So locate the centroid of the rod bent into the shape of parabolic arc as shown. Okay, so this is the rod bent shape of parabolic arc, and the equation of the parabolic arc is x equal to y squared. Okay, so we are going to use a differential element. Okay, so the differential element that we're going to choose is this one. Okay, so the length of the differential element is dl, and the location of the centroid of that differential element is at x curl and y curl. Okay, and also this point, okay, na x curl and y curl is also a point in the curve at arbitrary point. Okay, so that's why, okay, so that's why we have x curl here is equal to x and y curl is equal to y. The length and the moment arms. Okay, so dl, okay, is the length. dl is equal to square root of dx squared plus dy squared. Or, okay, we'll use the first formula, the second formula, is equal to square root of dx over dy squared plus 1 dy. Okay, so take note of this term. This is the first derivative of x with respect to y. Since x equal to y squared, we have dx over dy is equal to y. Okay, then from there, dl is equal to square root of 2y squared plus 1 dy. Okay, next slide. So first, for bar x, that is equal to square root of x curl dl over integral of dl. So that is equal to x times square root of 4y. Okay, so take note, this is x curl and this is dl. Okay, this one. Okay, so this is equal to integral of x times square root of 4y squared plus 1 dy over square root plus 1 dy. So ang limits natin will be from 0 to 1 because that is the limit, okay, or that is the domain ng length, okay, about the y-axis. Okay, we are integrating this with respect to y, so x should be as function dapat ng y. Okay, so replace x by its equivalent here, integral of y squared times square root of 4y squared plus 1 dy from 0 to 1 over square root of 4y squared plus 1 dy from 0 to 1. Okay, evaluating this integral and this integral, it will give you 0.6063 divided by 1.479. Okay, so it will give you bar x equal to 0. Okay, then for bar y, okay, so bar y is equal to integral of y curl dl over integral of dl. So that is equal to square of y times square root of 4y squared plus 1 dy from 0 to 1 divided by integral of square root of 4y squared plus 1 dy from 1. Denominator, okay, performing the integral. So we have 0.8484 divided by 1.479. Okay, and it will give you bar y equal to 0.57 meter. Okay, so any question? So if you have questions, you can unmute and you can ask your question. Then I answer your question. Okay? Or you can post it in the chat box. Then I'll read it, then I'll answer it. Okay? Pero kung walang tanong, we can proceed to the next example. Meron ba question? Inaantok. Okay, yung ganito oras talaga is medyo nakakaantok. No? Okay, so anyway, let's proceed to the next example. So sample problem 9.2. So locate the centroid. Okay, so in this time, we will use polar coordinates. Okay, so ano yung polar coordinates? So this point, okay, is at r and theta. Okay, so now, we'll choose a differential element. So this is a circular arc. Okay, so we'll choose this element na ang length ay dl. Okay, then from your trigonometry, arc length is equal to r times the subtended angle theta. Okay, so in this case, okay, this r is the capital R and the subtended angle is d theta. So that's why the length dl here is equal to r times d theta. Okay, now for the location of the centroid of the differential, you know that this is r. Okay, then if it will form a triangle here like this. If this is r, okay, so this is theta, what is this length? Okay, so that length is r cosine theta, while this height is r sine theta. And also, that would be the location of, or the curve, okay, for the differential element. Okay, so this should be theta plus 1 half d theta, but take note d theta is very small. Okay, dividing a very small number becomes very, very small. Okay, so that's why the effect of 1 half d theta can be ignored. X curl is equal to r cosine theta and sine theta. So now, for the length and moment arm, as I have discussed a while ago, dl is equal to r d theta. Okay? And x curl and y curl is equal to r cosine theta and r sine theta, respectively. Okay? Then from there, we apply integration. Okay? So, bar x, okay, from the formula, bar x integral of x curl dl over integral of dl. So that is equal to x curl is r cosine theta multiplied by dl is r d theta. Okay? Over integral of r d from 0 to pi over 2. So why the limits 0 from 0 to pi over 2? Kasi take note, we are integrating with respect to theta. So we need the mean, okay, of the curve or nung arc, okay, dun sa angle. So take note, theta is varying from dito papunta dun. Okay? Theta. So that is from 0 to what? Okay, 0 to 90 degrees, and in radians, 90 degrees is pi over 2. Okay? So that's why the limit is from 0 over 2. Okay? R and R are constant. So pwedeng lumabas dun sa integral. So we have R squared, okay, times integral of cosine theta d theta from 0 to pi divided by r times integral of d theta from 0 to pi over 2. Okay, so that will be equal to 2r over pi, and that is your bar x. Okay, then to solve for bar y, so bar y is equal to integral of y curl dl over integral of dl, that is equal to integral of r sine theta times r d theta divided by integral of r d theta, okay, from 0 to pi over 2. So that would be equal to r squared times sine theta d theta from 0 to pi over 2 divided by r times integral of d theta from 0 to pi over 2. So evaluating this integral and this integral, it will give you 2r. Okay? So that is the answer. So any question? So meron bang question? So, katahimikan. Okay? So, ibig sabihin, walang tanong. Okay? So, kung merong hindi mo rin may tanong, kasi hindi mo naman alam kung yung tatanong mo, kung ma-realize mo mamaya kung ano yung gusto mo itanong, okay? Just message me. Okay? Or habang nag-lecture pa, you can ask that question. Okay? So, next, we'll proceed to the next example. Sample problem 9.3. Okay, so determine the distance y measured from the x-axis to the center of the area of the triangle shown. Okay, so we have this triangle, base B and height h. Then this is the reference x and y axis. Okay, so this line, which is the hypotenuse of the triangle, is an equation of y is equal to h over b times b minus x. So if you are wondering kung saan nanggaling itong equation na to, it came only from y is equal to mx plus b. Okay? So now, we'll choose a differential element. So in this example, choose a rectangular strip. Okay? So if this point is in the arbitrary point x and y, okay, it gives that the base of this rectangular strip is x. Okay? And the height is dy. Okay? Then, okay, area, area and moment arms. So for the area, dA, so that's the area of the rectangle. Okay? So that is equal to x times dy. Okay? So ito yun. So that is x times dy. Then for, since this is dy, x as function of y. Okay? Then from this equation, by manipulating this equation, we can have the equation of x equal to b over h times h minus y. Okay? So if we have b over h minus y, for x, okay, multiplied by dy, so that will be your dA. Then for the moment arm y curl, so y curl is just equal to y. Okay? So the arbitrary point y. Okay? Then from there, we apply integration. So from the formula, bar y is equal to integral of y curl dA over integral of y curl is y. So we have it here, y, multiplied by dA. So dA is here. Okay? So b over h times h minus y dy. Integral of b over h times h minus y dy. So evaluating this integral and this one, it will give you 1/6 bh squared divided by, so simplifying this will give you bar y equal to h over 3. So that's the answer. Okay, so question. May question ba? Okay, so say you want to solve for the location of the centroid of this triangle, from this, use a vertical rectangular strip. Okay, say for that, the width of that strip is dx, and it, okay, so the centroid x curve will now be equal to x also. Okay, then from applying the same principle here, you can get bar x is equal to b. Okay, so you can try this, okay, later. Okay, that the bar x, the location of the centroid, okay, of the triangle, okay, parallel to the x-axis is b over 3. Okay? So dito, in this example, it proves that the centroid of the triangle is located at h over 3 of the height. Okay? So next, sample problem 9.4. So locate the centroid for the area of a quarter circle shown. Okay? So quarter circle. So we'll also use polar coordinates. Okay? So polar coordinates will be used. Just the element in the shape of a triangle. Elements intersect the curve at point R and theta. Okay, a circular sector. Okay, this one. Kaya lang, since this arc is very small, we can assume that this is a straight line. So that's why we can assume that this is instead of a circular sector. Okay, so if we assume that this is a triangle, based from the previous example, we know that the centroid, okay, of this triangle is at one of note of this triangle, it has a height r. So if this is at 1/3 of height, that is at r over 3. Then given that, okay, this length now will be what? 2/3 of r. Okay? So if this is 2/3 of r and this is angle theta, okay, the location of the centroid of and y curl equal to 2/3 r cosine theta and 2/3 r sine theta. Okay? Then, so for the area, okay, so since we assume that this is a triangle, okay, the area will be equal to the area of a triangle, which is 1/2 of the base, r d theta, multiplied by the height, r. Okay? Squared over 2 times d theta. Then, for x curl and y curl, that will be 2/3 r cosine theta and 2/3 r sine theta. This one, okay? Then next, we apply integrations. Okay? So for bar x, that is equal to integral of x curl dA over integral of d. So integral of 2/3 r cosine theta, which is your x curl, multiplied by dA r squared over 2d. Okay? Over, so limits will be 0 from pi over 2. Okay, so similar with the circular arc, the limits for theta for this quarter circle is from 0 to pi. Okay, so that will be equal to 2/3 r times integral of cosine theta d theta from 0 to pi over 2 over integral of d theta this na nag-cancel. Okay, so evaluating this integral and this one will give you 4r over 3 pi for bar x. Then for bar y, doing the same thing, bar y is equal to integral of y curl dA over integral of dA. So that is equal to integral of 2/3 r sine theta times r squared over 2 d theta divided by integral of r squared over 2 d theta. Limits will be from 0 to pi. Okay? So that will be equal to 2 times integral from 0 to pi over 2 over integral of d theta from 0 to pi over 2. Then from there, yan, solve for bar y. Bar y is equal to 4. Okay. So that's the value of bar y. Okay. So any question? Okay. So mukhang wala namang question, no? Okay, sige. So with that, we'll proceed to the next example. Pause ko lang muna. Okay, kasi naiiyak ako. Okay, so let's continue. Problem 9.5. Okay, the centroid of the area shown. Okay, so this is an example of area bounded by curves. Okay, so you have a curve which is y is equal to x squared. Then you have the curve x equals 1 and y equals 0. Okay, then what we're going to do is first choose a differential element. So in this case, we will choose a rectangular element. So the base of this rectangular element is dx and its height will be y. Since this point, okay, on this curve is arbitrary point x and y. Okay? Then the location of the centroid of this differential element at x curl and y curl, okay? And area. So area is dA is equal to y dx. So y dx. Then the location of the centroid of the differential element is at x curl equal to x and y curl is equal to y over. This is at x and the location of the centroid, since this is a rectangle, you know that the centroid is at h over 2. Okay, so in this case, your height is y. So that's why y curl is at y. Then we apply integration. So bar x is equal to integral of x curl dA over integral of dA. So that is equal to integral of x curl is x, okay, then dA is y dx. So from 0 to 1 over integral of y dx from 0 to 1. Since we are integrating with respect to x, y should be, okay, so what is y in terms of x? That is x squared. So we're going to replace y here by x squared. Then we have this integral of x cubed dx from 0 to 1 over integral of x squared dx from 0 to 1. So that is equal to 0.250 divided by 0.75 meter. So that's the value of bar x. Okay? Then for bar y, that is equal to integral of y curl dA over integral of dA. So that is equal to integral of y over 2, that is your y curl, y over 2 times dA is y dx. From 0 to 1 over integral of dx. So similar with this, we replace y with x squared since we are integrating with respect to x. Okay, and by doing so, we have these equations. Okay, so it's equal to integral of x squared times x squared dx from 0 to 1 over integral of x squared dx from 0 to 1. So that is equal to, okay, 0.1 over 0.5. That is equal to 0.3 meter. Okay? And that is the value of bar y. Okay? May question ba? Okay? So I think mukhang namang walang question. So we'll proceed to the next example. In 6, locate the y-centroid for the paraboloid of revolution as shown. Okay? So this time, the example is a volume. So since this is a volume, our differential element should also has a volume, dV. Okay? So as for the differential element, okay, we'll consider an element having the shape of a thin disk. Okay? Then it intersects the generating curve at the arbitrary point 0, y, z. And therefore, its radius is r is equal to z. Okay? So thin disk siya. Okay? And this thin disk like a cylinder, a very thin cylinder. Okay? That's why its thickness is just dy. Okay? Now, for the volume and moment arm, since sabi ko nga, the element will be dv is equal to pi z squared dy. So it should be pi r squared dy, but since r is equal to z, based from this arbitrary point. So dv is equal to pi z squared dy, and its centroid will be located at y curl, okay, which is equal to y also. Okay? So y curl is equal to y. So apply integration. So we have bar y is equal to integral of y curl dv over integral of dv. So that is equal to integral of y from 0 to 100 divided by pi z squared dy from 0 to 100. Okay? So, but we are integrating with respect to z squared should be a function of y. Okay? So, since we have this equation of the curve, z squared is equal to 100y, we'll replace z squared here by 100y. Okay? Then, by doing so, so we have 100 pi times integral of y squared dy from 0 to 100 divided by 100 pi dy from 0 to 100. Okay, so evaluating these integrals, it will give you bar y equal to 66.7 millimeters. Okay, so that is the answer. So question. Okay, so mukhang wala namang question. So we proceed to problem 9.7. So determine the location of the center of mass of the cylinder shown if distance from its base, 0 is equal to 200 z kilograms per cubic meter. Okay, so if the cylinder has a constant density, okay, we know that the centroid of the cylinder will be at the middle. Okay, will be at one half of the height. Okay, but in this example, okay, the varies with the distance from the base. That's why rho is equal to 200 z. Then based from that, we need to locate the center of mass by applying integrations. Okay, so the differential element that will be considered is as in this also. Okay, then for reasons of material symmetry, bar x and bar y is equal to 0. Okay, so for the differential element, a dv of radius 0.5 meter and thickness dz is chosen for integration. So this is similar to the previous problem where we choose an element which is in the form of a thin disk. Okay, so the element is located along the z-axis at the arbitrary point 0, 0, and z. Okay, so this is the standard equation. Okay, then volume and moment arm. So the volume of the element is dv is equal to pi times 0.5 squared dz. Okay, take note this is the area of the disk multiplied by the thickness dz, and its centroid is located at z curl is equal to z. Okay, so take note the centroid of this thin disk is also equal to z. Okay, so from there we apply integration. So z bar z is equal to integral of z curl rho dv divided by integral of rho dv. Okay, so that is equal to, so z curl z, okay, rho is the given rho, which is equal to a function of z, so 200 z. Okay, so then multiplied by dv, pi times 0.5 squared dz. Okay, divided by integral of 200 z rho times dv pi times 0.5 squared dz from 0 to 1 meter. So that is equal to, so 200 will be cancelled, pi times 0.5 squared will also be cancelled. Okay? So matitira dito of z times z dz or z squared dz divided by integral of z dz. Okay? From 0 to 1. So evaluating those integrals, it will give you bar y equal to 667 meter. So that's the answer. Okay. So any question? Okay. So if you have questions, you should ask. No? Kasi ang nangyari pa ganito, I'm assuming, okay, na pag walang tanong, either naintindihan talaga problem. Then sabi ko, kung hindi nyo ma-compose yung question nyo ngayon, you can ask on a later time. Okay, you can send me a message on Facebook. Okay? Okay, so kung walang question, we'll proceed to the next topic. Okay? Okay? So a composite body consists of a series of connected simpler shaped bodies which may be rectangular, triangular, semicircular, etc. So such a body can often be sectioned or divided into its composite parts, and provided the weight and location of the center of gravity of each of these parts are known, we can then eliminate the need for integration to determine the center of gravity for. So rather than account for an infinite number of differential weights, we have instead a finite number of weights. Okay, and the formula that we're going to use will be bar x equals summation of x curl w over summation of w. So bar y is equal to summation of y curl w over summation of w, and bar z is equal to summation of z curl over summation. Note, take note in this formula, we remove the integral and we replace it with summation. Okay, so that's why the need for integration has been removed since we are using composite parts. Okay, so in these formulas, bar x, bar y, and bar z represent the coordinates of the center of gravity g of the composite body. X, Y, Z, X curl, Y curl, Z coordinates of the center of gravity of each composite part of the body. And summation of W is the sum of the weight of all the composite parts of the body, or simply the total weight of the body. Okay? So when the body has a constant density or specific weight, the center of gravity coincides with the centroid of the body. So centroid for composite lines, areas, and relations analogous to the previous equations. However, the W's are replaced by L's, A's, and V's respectively. So meaning, if the composite body lines, areas, and volumes, okay, will replace W's by L's, A's, and V's respectively. Okay, so we apply the same formula, but instead of A or V. Okay, then centroids for common shapes of lines, areas, shells, and volumes that often make up a composite body are given in the following table, or you can look at the inside back cover of the reference book. Okay? So the values, okay, or the formulas shown here in these tables are from the table on the inside back cover of your book. Okay? So these are the common geometric properties. So the area moment of inertia, you can ignore it for now. Okay, so it will be discussed on chapter 10. Okay, so we'll just focus on these formulas. Okay, so for example, you have a circular segment. Length of that circular arc segment is 2 theta times r, and the location of the centroid with respect to the given x and y axis will be r sine theta over. Take note, theta here is in radians. Okay, the next, quarter and semicircle arcs. Okay, the location of the centroid is at 2r over pi. These are been go. And for semicircle arc, that is also 2r over pi. Okay? Then if you have a circular sector, so this is the location of the over 3 pi, 4r over 3 pi as shown in the previous examples. Okay? So yun. So since we know the centroid of these common geometric shapes, okay, we can remove the integration part dun sa mga solution natin if we are solving composite bodies. Okay? So next, if you have a trapezoid, okay, so I would suggest that will not be included in your memorization of the formulas because as considered as composite area, okay, with a rectangle and say two triangles. Okay? So I would suggest na wag nang i-memorize yung formula for trapezoidal area. Okay? Then if you have a semi-parabolic area, you have a semicircular area, and circular area, these are the location of the centroid. Okay, so but take note, using these formulas, okay, these are the location of the centroid with respect to the given x and y axis. Okay? So pag nagbago yung location ng x and y axis mo, okay, the location to the centroid of the area is still there. Okay? Pero the distance of the centroid from the reference axis will be changed. Okay? For example, in this circular area, bar x, okay, y, okay, because the centroid of the circular area, okay, lies or coincides, okay, with the origin. That's why bar x and bar y is equal to 0. Okay? But if you're going to have reference x and y axis, like this one, x and y, okay, the reference, the centroid bar x and bar y will no longer be 0. Okay? Bar x and bar y will no longer be 0. So this will becomes r and r. Why? Because the distance now of the centroid from the origin parallel to the x and y axis are, okay? So if this is the centroid, the location of the centroid is at distance r from the x-axis, which is bar y, and distance r from the y-axis, which is bar x. So, kumbaga, you have the formula, yes, okay, but you should know how to use the formula, okay, in applying the principle of centroids for composite bodies. Okay, so these are just references. You should know how to use the formula. Okay. Then you have the formula for x parabolic area. Then if you have a rectangular area. Okay? So, nasa libro din naman yan and nasa lecture din. Okay? So, ang ano ko lang, you should know how to use the formulas. Take note of the reference axis. Okay? So, next, center of gravity of homogeneous solids. So, ignore yung mass moment of inertia. Okay? So, if you have a sphere, so that will be, the volume is at cube. Okay? And the center of gravity is, we know, at the center of the sphere. Okay? If you have a cylinder, the volume is pi r squared h, and the location of the centroid is at h over cylinder. Okay? Then if you have a hemisphere, okay, with radius r, the volume is equal to 2/3 pi r cube, and the location of the centroid or the center of gravity is at 3h r from the base of the hemisphere. Okay? Then if you have a cone, the volume is 1/3 pi r squared h, and the location of the center of gravity is at h over 4 from the base. Okay? So, yan lang yung mga formula natin. Okay? Kaya kumbaga, the need for integration will now be removed in our solution. Because what are we going to do is, if you have a composite body, just divide that composite body into composite parts where we know the weight and the center of gravity. Or we know the area, geometric area, and the location of the centroid. Okay? So, sample problem 9.8. So, locate the centroid of the wire shown. Okay? So, this is a composite line. Okay? So, since composite line siya, we can divide it into we have three composite parts, this semicircle, this line, and this line. Okay? So, we have it here. So, this is the first side composite part. This is the second composite part, and this is the third composite part. So these composite parts, we know the length of the lines, we know also the location of this line. Okay? Kaya we can consider this as composite, and we don't need integration here to solve. Okay? And if you have composite bodies, it is suggested to use a solution in tabular form like this one. Okay? So we have columns for the length, column for x curl, y curl, and z curl. Okay? Column for the product of x curl and L, y curl and L, z curl L. Kasi we know, if we get the sum of this x product of x curl and L, that is summation of x curl times L. And if we get the sum of these lengths, that is the summation of length. Then we know that from the formula for centroid, bar x is equal to summation of xl over summation. We can solve for bar x by dividing the summation of product of x curl and L by the summation of the length. Okay? So yun. So gawin natin, isa-isahin natin. Okay? So segment 1 is a semicircle. And we know the length of the semicircle is pi times r. Okay? So that's why we have here pi times 60. So that is equal to 188.5. Okay? Segment 2, okay, is this one. So the length of segment 2 and segment 3 is 20. Okay? So getting the sum, we have 248.5. X curl. So X curl is the distance of the centroid of the segment from the origin parallel to the x-axis. Okay? This is segment 1. What is the distance of the centroid of segment 1 from the origin parallel to the x-axis? Okay? 60 millimeters. Kasi this is the centroid. Okay? So ano ba yung distance niya papunta dun sa origin parallel to the x-axis? So that is 60 millimeters. So that's why we have it here. Okay? For segment 2, okay, alam natin the centroid is nandun sa kalahati. Okay? So what is the distance, okay, nitong centroid na to parallel to the x-axis? Okay, so since nandito siya sa y-axis, okay, ano yung distance niya parallel to the x-axis? 0. Okay, so that's why we have it here, 0. Okay, while this one, the centroid of this is here, but the distance of the parallel to the x-axis is also 0. Okay, kaya we have the value. Okay, for the y curl, so ito yung y curl. Ito yung centroid ng segment 1. So what is y curl? So y curl is the distance of this centroid parallel to the y-axis. Okay, that's y curl. So based from the formula, if you have a semicircle, the location of the semicircle from this base is equal to 2r over pi based on the formula. Okay, that's why this distance is 2r over pi. 260 over pi equal to 38.2. Okay, so but this centroid, this point, is found to the left of the origin. So nandun siya sa side y, the negative sign here. Okay? Kaya y curl nung element nung segment 1 is negative 38.2. Okay? So for segment 2, the location of the centroid is here. Distance from origin parallel to the y-axis is 20 millimeters. Okay? While segment 3 is the location of the centroid from the y-axis gives you 40. Okay? So those are the values of y curl. Then for the z curl, that is the distance of the centroid parallel to the z axis. So for element 1 or for segment 1, so since this is lying in the xy plane, so the distance of the centroid from the origin, 0. Okay? So for segment 2, Okay, the distance of the centroid of this from the origin parallel to the z-axis is also 0. While for segment 3, okay, this is the location of the centroid that is 10 millimeters, okay, from the origin parallel to the z-axis. And since this is found below the origin, the okay, so kompleto na yung x curl, y curl, and z curl. We can now get the product x curl times L, y curl times L, z curl times L. Okay? So by multiplying those, okay, we have these values, this one and this. Okay? And the summation, so we have summation of x curl times L is equal to 11,300. Summation of y curl times L is negative 5,600, while summation of z curl times L, okay, is equal to negative 200. Okay? So based from there, so from the formula of centroid, bar x equal to summation of x curl times L over summation of L. So this value here will just be divided by this value here. For x, 45.5 millimeters. Then same with bar y and bar z. So you just divide the value here by this one. So solve for bar y and bar. So question. Okay? So, it seems na walang question. So, we'll proceed to the next example. Oy, may question. Ay, hello pala. Okay? So, next example, locate the centroid of the plate area shown. Okay? So, if you're going to solve this problem, I will divide this into three composite parts. Okay? So, the first composite part is this square, this one. The second composite part is this one, and the third composite part is this one. The composite body into composite parts, okay? So it will depend on your preference. Okay? Like this one. So sabi ko, if I'm going to solve this problem, I will divide this into these three composite parts. But the reference book, okay, ganito yung ginawa niya. Okay, na composite parts. Okay? Inassume niya na ito ay buong rectangle, square. Okay? Then this will be subtracted, this rectangle here. So, mangyari, this plus this minus this one will give you this composite area. The same. Okay? The result will be the same. So, it doesn't matter how you divide the area. Kasi the centroid of that area will be the same. Okay? So, yun. So, depende na lang kung gaano mo gustong kadali o mahirapan dun sa pipiliin mong composite parts. Okay? So, if of the part, second composite part, and third composite part, we solve the location of the centroid. Okay, so since this is plane area, we need to solve only for bar x and bar y. Okay, so for segment 1, okay, we considered a triangle. Okay, and the area of the triangle is 1/2 of base times height. So we have 1/2 of 3 times 3. So that's 4 squares. So that's 3 times 3 equals 9. And segment 3 is a rectangle with base 1 foot and height 2 feet. Okay? So the area is 2. Okay? Okay, this is negative because this area will be subtracted from this to arrive with this composite area here. Okay? So, so 11.5. Then about x curl and y curl for each segment. Okay? So the location of the centroid of a triangle is at b over 3 and h over 2. Okay? So the base of the triangle is 3 feet. So thus the location of the centroid is 1/3 of 3. So it's 1 foot. While the location of bar y, or y curl, for this triangle is 1/3 of the height. So it's 1 foot. Okay? So thus the input here, 1. Okay? For the second segment, okay, so since this is a square, so alam mo, this is just b over 2 and h over 2. Okay? So this is, if this is 3 feet, so the location of the centroid is 1.5 feet and 1.5 feet. Okay? But since this centroid is found to the left of the origin, okay, the negative. Okay? Then y curl is 1.5 feet, okay, because it is above the origin, positive. Okay? The rectangle which will be subtracted, okay, the location of the centroid is here. So if that is a rectangle, okay, the location of the centroid is 1/2 of the base here. So kaya 0.5. Kaya lang, the location of the centroid should be referred to the origin. Okay, kaya this is 0.5 plus 2 feet because this is 2 feet. Okay, the location of x curl is 2.5. And since this is found to the left of the origin, the sign is negative. Okay, so it's negative 2.5. Okay, and y curl, the location of the centroid is 1 of height. So if this is 2 feet, this is 1 foot. But since we are going to refer it from parallel to the y-axis, so 1 plus we have 2 feet here. Okay? So may value ka na ng x curl and y curl. You have the area. You can get the product x curl A and y curl A. So these are the values. Get the summation of x curl A and summation of y curl A. So that's negative 4 and 14 respectively. Then from there, you can solve for bar x and bar y by applying the formula. Okay? Or dividing this by this and this by this. Okay? So bar x equal to negative 0.348 feet and bar y is equal to 1. Okay? So any question?
Sir,
Yes po.
paul-
Choppy. Choppy. Question? Yung nagka-question kanina. Pwedeng i-chat. Okay, kung uh, Sir, yung sa segment 2 po, yes po, what's the problem with segment 2? Pwede po paulit? What do you mean? The area? This one? And the x curl and y curl? Okay. So for segment 2, okay, since this is a square, okay, so the area is 3 feet by 3 feet. Okay, kaya 9 foot. Then the location of the centroid of this square, syempre, nandito sa gitna. And this distance is b over 2 and h over. So this is 3 feet, okay? The location of the centroid from the origin, kasi tigno, this is the origin. Okay? The distance of the centroid from the origin parallel to the x-axis. Okay? So it's 1.5 feet. Okay? Then the distance of the centroid from the origin parallel to the y-axis is 1.5 feet. Is 1.5, y curl is 1.5. So y the sign for x curl is negative. Okay, the sign for x curl is negative because the centroid of this segment is found to the left of the origin. Kasi this is the positive x. This is negative x already. Okay? Kaya this location of the centroid negative. Kaya negative 1.5. Nakuha na.
Sir, ang feel siya, mayroon pong block po para hindi po maging kumpleto po na 3 feet.
Ano? Hindi. Kasi ang ginawa dito, di ba, ito yung original na composite body. So, ang ginawa nung solution, inassume niya na buo to. Okay? Tapos, para bumalik pa rin tayo dun sa original na composite body, we have a segment. This one. Okay? Sinubtract to. 3. Kaya yung area nung segment 3 is negative. Okay? Nakuha na?
Yes po. Nakagets ko na po. Yes po.
So, how about the others? Diba? Okay? So, mukhang wala ng question. So, let's proceed to the next example. So, sample problem 9.10. So, locate the center of mass of 2 mass density of rho C is equal to 8 megagram per cubic meter, and the hemisphere has a density of rho H is equal to 4 megagram per cubic meter. There is a 25 millimeter radius cylindrical hole in the center of the frustum. Okay, so if you guys are going to solve this problem, how many composite parts are? So 4. So alin yung 4 na yon? Okay? So normally it's 3. Kumbaga, parang normally, if you're going to look at this, you have 3. First is the conical frustum. Second is the hemisphere. The third one is the cylindrical hole. Okay, kasi wala naman tayong formula from the tables for a conic frustum. So, we can and the centroid for a conical frustum. So, since wala, what are we going to do is, i-assume natin na meron cone dito. Okay, kasi volume and centroid, center of gravity for a cone. Okay? So, i-assume natin na buong cone to and the cone. So, similar dun sa ginawa dun sa previous sample. Okay? A full cone here minus a cone here, okay, you know the volume, right? Center of mass or center of gravity, center of volume of those. Okay? Kaya ang magiging composite parts natin will be 4. Okay? So these are the 4 composite parts. Okay? So first is the full cone. Okay? Full cone. Second is the hemisphere. Third is a cone, which will be subtracted. And third is the fourth cylindrical hole. Okay? So if we add this and we subtract this, we'll arrive with the composite body which is given. Okay? So mag-arrive tayo dun sa given na composite body. Okay? So to solve for the location of mass, okay, center of mass, so ganun pa rin, similar with the example in tabular form. Okay? So take note, mass here is equal to density times the volume. Okay? So these values are the densities, these are the volumes. Okay? So segment 1, okay, this is a cone. So the formula is 1/3 pi r squared h. So kaya we have 1/3 pi r squared h. Then the density is 8 times 10 to the negative 6. So take note, 8 times 10 to the negative 6, this is in kilograms per cubic millimeters. Okay? The given na 8 megagram per cubic meter, it has just been converted into kilograms per cubic millimeters. Okay? Then segment 2 is density. Segment 2 is a hemisphere. So volume of the hemisphere is 2/3 pi r cube. Okay? Then for the okay, dun sa third is density times the volume. So 1/3 pi r squared h. So 1/3 times pi times 25 squared. Take note of the negative sign. The negative sign here indicates that it will be subtracted. Okay? Then for the whole, cylindrical hole, so that is the volume of the whole is pi times 25 squared times 100 multiplied by density. Okay? Then get the sum of this. Okay? Get the sum of this, unit of the mass. Okay? So, ito yung sagot niyan, 4.189, 1.047, negative 0.524, and negative 1.571. Okay? So, get the sum of this. This is the Then, for Z curl, the location of the centroid from the reference, from the origin. Okay, dito. So, Z curl for element 1, okay, or for segment 1, since this is a cone, from the formula for solids, okay, the location of the center or centroid ng cone is at h over 4. So, if the height is 200, the location is at 50. And this centroid is above the origin. So that is positive. Okay? Then for the hemisphere, okay, location of the centroid is at 3/8 of 50. Or 3/8 of 50, that's 18.75. Okay? So since the centroid of this hemisphere is found below the origin, the sign is negative. Okay? Then next, for the third segment, yung cone. Okay? So if the height is 100, the location of the centroid is 1/4 of the height. Okay? Kaya 50 meters. But take note, we are taking the distance of the centroid from the origin. Kaya it's 25 plus 100. So that is equal to 150. Okay? So, then for this one, for the cylindrical hole, the location of the centroid is at h over 2. So if the height is 100, okay, the centroid is at h over 250. Okay? So may value ka na ng Z curl, may value ka ng masses, okay, you just multiply. Okay? So M times mass. Okay? Then get the sum of this. Okay, you have summation of Z curl times M. Okay? Then dividing this summation by this summation, you'll arrive with Z bar. Okay? So bar Z, this should be bar. So bar Z is equal to summation of Z curl M over summation of M. 13.6 millimeters. Okay? Question. Walang question? Naintindihan naman? Walang question, we'll proceed to the next topic. Okay, so 9.3, theorems of Pappus and Guldinus. Okay, so the two theorems of Pappus and Guldinus are used to find the surface area and volume of any body of revolution. So they were first developed by Pappus of Alexandria during the 4th century AD, and then related to the mathematician Paul Guldin or Guldinus. So two theorems of Pappus and Guldinus, and the first theorem is the surface area. Okay. So if we revolve a plane curve of an axis that does not intersect the curve, we will generate surface area of revolution. Okay. And the area, surface area of revolution will be equal to R times L. Okay. Where theta is the angle of revolution measured in radians, and it should be less than or equal to 2 pi. Bar R is the perpendicular distance from the axis of revolution to the centroid of the generating curve, and L is the length of the generating curve. Okay? So for example, if we have this plane curve here na L, this one, is at C. So yung bar R is the distance of this centroid from the axis of revolution. Okay? And that is your bar R. Okay? Multiplied by the length and multiplied by the angle of revolution, that will be the surface area of revolution. Okay? Kasi take note, if you're going to revolve a plane curve about a non-inverted a surface area. Okay? And based from there, therefore, the first theorem of Pappus and Guldinus states that the area of a surface of revolution curve and the distance traveled by the centroid of the curve in generating the surface area. Okay? Then the second theorem of Pappus and Guldinus is so volume can be generated by revolving a plane area about an axis that does not intersect the area. Okay? So the volume of times bar r times 8. Okay? Where theta is the angle of revolution measured in radians. Okay? And it should be less than or equal to 2 pi. Bar r is equal to revolution to the centroid of the generating area. A is the generating. Okay? So imagine if you have a plane area like 8, a volume. Okay? Or it will generate a volume. Okay? And the volume generated is defined by this formula. So this, and this is the perpendicular distance of the centroid to the axis of revolution. Okay? So yun. So that is the second theorem of Pappus and Guldinus. So based from there, okay, we have the second theorem of Pappus and Guldinus, and it states that the volume of a body of revolution equals the product of the generating area and the distance traveled by the centroid of the area in generating the volume. Okay? Let's have an example. So sample problem 9.11. So show that the surface area of a sphere is A is equal to 4 pi r squared and its volume is V is equal to 4/3 pi r cube. Okay? Paano yun? So, let's say we have a semicircular arc like this one. Okay? And if we're going to revolve by one complete revolution about the non-intersecting x-axis, it will generate the surface area of a sphere. Okay? So the of this semicircular arc is at this point, which is 2r over pi, then the surface area of revolution will be equal to theta r. Okay? And we know that theta is equal to 2 pi since we have a one complete revolution. Okay? Then bar r is the distance of the centroid perpendicular to the axis of revolution. Okay? So that is
Gago.
equal to 2r over pi. Bawal magmura dito. Okay? So 2r over pi. So bar r is 2r over pi. Then the length of the curve, okay, the semicircle arc is pi r. Okay? So therefore, the area is equal to r squared. Okay? Then for the volume, okay, we have a semicircle, and this semicircle will be revolved revolution. If we're going to revolve this about the x-axis by one complete revolution, okay, we know that the centroid of the semicircle is at 4r over 3 pi. Okay? So the theorem of Pappus and Guldinus, okay, for this volume, okay, volume is equal to ta times r sig. Theta is 2 pi. Okay, since ano siya, one complete revolution. Bar r is this one, the perpendicular distance. So we have 2 pi r